Next, let us try to understand a numerical based on a stable multivibrator. The problem statement will be like this: in a stable multivibrator using IC555 timer, calculate TC means charging time, TD means discharging time, and output frequency, that is F, we need to calculate, and we have been given the value as value for RA, RB and C. You just have to substitute the value and get the answer. Okay, so we start with the charging time. The formula, when the capacitor charges through RA and RB, so that is how you have to remember: 0.693 RA plus RB into C. Okay, so charging time will be 0.693, RA plus RB will be 10 into 10 plus 20 kilo ohms, that is into 30 kilo ohms, 30 into 10 to the power 3, multiplied by capacitor is 100 microfarad, 100 into 10 to the power minus 6. So TC will be 0.693 multiplied by, I can write this as 3 into 10 to the power 4, and here I can write it as 1 into 10 to the power minus 4. So this 2 gets cancelled, so this value will be TC is equal to 0.693 multiplied by 3. .079 seconds. Okay, so this is your charging time. Similarly, the second part will be discharging time. And what is discharging time? While discharging, it discharges through RB, so it is 0.693 RB into C. So it will be 0.693 20 into 10 to the power 3, that is 20 kilo ohms, and 100 into 10 to the power minus 6 because 100 microfarad. Okay, so this value will be 0.693 into 2 into 10 to the power 4, 1 into 10 to the power minus 4. This 2 gets cancelled, so it will be 0.693 multiplied by 2, it will be 681.386 seconds. So we have calculated TC, we have calculated TD, and last one is frequency. The formula for frequencies, F is equal to 1.44 upon RA plus 2RB into C. So 1.44, what is RA? RA is 10 kilo ohms, so I'll write 10 plus 2RB, what is RB? 20, 20 into 2 is 40, 40 into 10 to the power 3, that is kilo ohms, multiplied by capacitor value, which is 100 into 10 to the power minus 6. So F is equal to 1.44 upon, this value will be 50 into 10 to the power 3 multiplied by 100 into 10 to the power minus 6. F is 1.44, this value will be 5 into 10 to the power 4 multiplied by 1 into 10 to the power minus 4. These 2 gets cancelled, so it will be 1.44 upon 5, which the value of which will come out to be 0.288, and the unit of frequency is hertz. So this will fetch you 3 marks. Okay, so this question can be asked for 3 marks. So make sure that all these problems are very easy. You just have to remember the formula, you just have to substitute the value in that formula and you will get the answer. And of course you should not make any mistake in the mathematical part of that. Okay, so I hope you have understood. Thank you. So students, the next application of IC555 timer is pulse amplitude modulation, PAM, pulse amplitude modulation. Of course we will be understanding is using IC555 timer. In the first class itself I have told you what exactly I mean by modulation. In modulation, modulation is necessary when you cannot transmit signal directly into the medium. We need to change the characteristics of the signal before transmitting the signal into the medium. So that process is called as modulation, and of course at the receiver end there will be a demodulator which will demodulate the signal and original signal will be received, accepted and processed. Okay, so that is what is there. So in this pulse amplitude modulation, we will connect a continuous varying signal into pulse. Okay, digital pulse we will convert, but we will keep the amplitude, that means strength of the signal, that is the amplitude of the signal same as that of the input. Of course we will use IC555 timer for that. Okay, so when I say continuous varying signal, so it will be like this. So this is the continuous varying analog signal. Okay, this is T, this is time period, this is V with respect to T. Suppose this signal has to be transmitted, but we cannot transmit this signal directly into the space. So what we have to do is we have to convert it into pulse, but the amplitude of that pulse should be exactly similar to what the input signal should be. Okay, so this is the input signal. So what we do is we just pass this signal through a transistor which is acting as a switch. Okay, we call this as gated circuit. As the transistor is acting as a switch, what will happen? It will be 0, 1, it will be in cutoff region, it will be in saturation region. When saturation region, that means the transistor will be in on state, so signal can pass through the transistor. But when the transistor is in cutoff region, the transistor act as a off switch, so no signal will be transmitted. Okay, so that is how we can convert the continuous analog signal into pulse form. Okay, so for that what we do is the transistor, the input for the transistor is a mono short. That means mono stable multi vibrator. And what is monostable multivibrator? The output remains 1 for a small duration of time, and again it will come back to 0 whenever triggered. Okay, so that is the condition. And the input to the mono short will be a stable multi-vibrator. A stable multi-vibrator where the output will be continuously 0 1 0 1 0 1 0 1. So every time when the stable output goes from 1 to 0, 1 to 0, 1 to 0, what happens is every time it goes from 1 to 0, this output will be given to the pin number 2 of monostable. And whenever pin number 2 of a monostable multivibrator is grounded momentarily, what happens? It triggers the output, the capacitor starts charging, the output becomes 1, and it becomes 1 for how long? Till the capacitor voltage becomes greater than +2/3 of VCC, and then it will come back to its initial position. So that is how the trigger pulse will be generated. And when monoshot's output becomes 1 for that per small duration of time, the input for the transistor will be 1. The transistor will be acting as a closed switch. That means it will be in saturation region, and when it is in saturation region, input signal will be transferred to the output. Okay, so input signal will be transferred to the output, and what you are going to get is you will get a small portion of input at the output in the form of pulse, for which the pulse width is for which the transistor remains in saturation region. The condition is the time period for which the monoshot remains 1. Okay, so for that particular period of time the output will be 1, and then what happens is monoshot will remain 1 for a small duration of time, and then it will become 0. As soon as it becomes 0, this will be 0, the transistor will be in cutoff region, input signal will not be transferred. Again the second clock pulse will arrive, the second clock pulse will trigger the monostable will generate one more pulse. For that particular duration of time, the input for the transistor will be 1, the transistor will be in saturation region, input signal will be transferred to the output. Okay, So what happens is the amplitude is same, that means the amplitude is same as that of the input signal for the output signal, but what we are doing is we are converting a continuous analog signal, continuously varying analog signal into a pulse form. So what you are going to get at the output will be something like this. Okay, so this is pulsed output, okay, or we can say PAM, pulse modulating signal, which is what you are going to get at the output. Okay, so this will be your output signal. So we have converted a continuous varying signal into a pulse amplitude modulated signal, which will be our output signal, by using transistor, monostable and astable multivibrator. Of course, to design monostable and astable, we will be using IC555 timer. So this is one of the application of IC555 timer. Okay, so this is an example where you are converting an analog signal into digital before transmitting the signal into medium. Okay, so this is all about pulse amplitude modulation. I hope you have understood. Hello student, the next application of IC555 timer is FSK, frequency shift keying. Here what we will do is, if you remember in pulse amplitude modulation, what we did is continuously analog varying signal is converted into pulse, analog to digital. Here we will convert digital signal where the digital inputs will be 0 and 1 into a signal which has a certain frequency, different frequency for 0 and different frequency for 1. Okay, so for that what I'm going to use is, I want you to see the circuit diagram and tell me what circuit I have drawn. 8 and 4 connected to plus VCC, 1 always connected to ground, pin number 5 is connected through a capacitor of 0.01 microfarad, pin number 3 is output, pin number 7, pin number 6, pin number 2. Pin number 6 and 2 are connected together. Between pin number 7 and plus VCC we have a resistance RA. Between 7 and 6 and 2 we have RB, and between 6 and 2 and ground we have a capacitor, and this circuit has been designed using IC555 timer. Okay, so we have already seen this circuit diagram. Now of course you have to link this circuit only, we can compare it only with the two circuits, either it will be for monostable or astable. But if you remember, in monostable multivibrator what we do is, pin number 2 is triggered externally by a switch, push to on switch, and pin number 6 is connected to pin number 7. And in case of a stable multivibrator, pin number 6 and 2 are connected together, and the potential for that pin number 6 and 2 will be given from the potential across the capacitor. So that is how you have to remember. One more thing which you can understand is, in monostable multivibrator only one resistance is used for charging. Discharging should happen immediately. Okay, but in case of astable multivibrator, there is charging time, there is discharging time. That means two resistance will be used. Okay, one for RA and RB for charging and RB for discharging. So that is how you have to understand. So of course the circuit diagram which I have drawn is for a stable multivibrator, where the frequency of the output F is given by 1.44 upon RA plus 2RB multiplied by C. Okay, see the modification which I am going to do in this circuit, so that it converts a digital signal into an alternating frequency. Okay, so what I will do is, I will connect between RA, I will connect a transistor and a resistance. So say resistance is R1, the transistor is Q1, and this is the input. Okay, this is the digital input. Okay, now when the digital input is 0, it's very easy for you to understand. Now the transistor Q1 is acting as a switch. Okay, when input is 0, the transistor is in cutoff region. That means transistor is in open circuit form, and when it's open, no current will flow. So when no current will flow, you just imagine as if there is no circuit in parallel to RA. So the circuit becomes exactly similar to what we have done for our stable multivibrator. So the formula for frequency is 1.44 upon Ra plus 2Rb into C. So this is the output frequency when the input is 0. So I'll write f of 0. F of 0 is 1.44 upon Ra plus 2Rb into C. Now see what happens when the digital input is 1. When the digital input is 1, the transistor goes into saturation region. When the transistor goes into saturation region, it works as on switch. Current flows through the transistor. Assuming the resistance of the transistors to be idle, that is 0, what happens now is this Ra comes in parallel with this R1. So between these 2 points, right, these 2 points, the resistance will change. Initially it was only Ra, then now R1 comes in parallel with Ra. So what will be the formula? 1.44 upon Ra parallel R1 plus 2Rb multiplied by C. So this is frequency when the input is 1. So f of 1 is 1.44 upon Ra plus R1 plus 2Rb into C. So this is the signal. See what happens is most of the time, for example, when I talk about modems, modulation, modulator and demodulator, we relate this modem word to internet. So what happens is the signals are transmitted through telephone lines. Okay, and telephone lines cannot transmit 0 and 1 digital signals. It has to be converted into frequency. Okay, so what we do is we use this FSK, frequency shift keying, where 0 corresponds to one frequency and 1 corresponds to another frequency, and the bandwidth for telephone line is 30 hertz to 30 hertz to 30 kilohertz. So we have to get an output frequency within this range. So by selecting the value of Ra, Rb and C, we can select that we select that variations so that it remains under that bandwidth but produces 2 different frequencies for 0 and 1. So this is how we convert a digital signal into an analog frequency by the circuit FSK, where the important part is IC555 timer. So this is one more of the application. This is one more of the modulation process where IC555 can be used.